Good morning, children. Today we will start physics topic. So in this topic, here both combination will be there in your school, CBSE and this state board of SSC. So that's why first of all I am explaining about for this slide topic. So what's the given in state syllabus? Then after, if any additional matters will be there, that will be continued for CBSE classes. So for the children, so listen carefully. Now the both combination topic will be light. So it's somewhat different from this CBSE and state board syllabuses. So both common syllabus will be there. That is refraction of light at plane surface. So before discussing this, nature of the light. Nature of the light. Nature of the light first we have to discuss. Light nature can be explained by four different theories on it. So already in previous classes, especially for CBSE syllabus students to learn. So already know, but once again I repeated for all of them. Nature of the light is important. For explaining this nature of the light, four different theories explains the nature of the light. In that, first one is said to be the corpuscular theory. Corpuscular theory of light. Corpuscular theory of light. Second one, wave theory of light. Wave theory of light. Third one, electromagnetic theory of light. Electromagnetic theory. Electromagnetic theory of light. And fourth one will be Planck's quantum theory. Quantum theory. These four theories explains about the nature of the light. So in that, this corpuscular theory, four different scientists proposes these four different theories. This corpuscular theory proposed by Newton proposed this theory. Corpuscle means a small particle, means light propagated in the form of a small particle, extremely a small particle. That first given by this in 17th century by Newton. So Newton stated light produced in the form of an extremely small particle. Such a small particle is called as corpuscle, and this theory is known as corpuscular theory. It means light propagated in this form. So these are the particles. In this way, light will be propagated straight line motion and shed. So in this way, light will be propagated. This is called particles or corpuscles. So theory will be there, but explanation already you know. Just only I am giving up the names and theories, different theories of the scientists here. Next, wave theory. Wave theory of light proposed by Huygens. Huygens stated wave theory of light. So it is not a particle nature. Light is not a particle nature. It is in the form of a wave nature. So wave means it will produce light. So light is also in this manner. Straight line motion only light will be travels. So according to this Huygens, light propagates in the form of a wave. So it is different from the corpuscular theory. But actually, for the production of this wave, compulsory particles are needed. The vibrations of the particles can produce these waves. That's why particles are also important. But these two different theories explain about different natures. So Newton says it's a particle nature and Huygens says it's the wave nature. But another theory says electromagnetic theory of light. It is proposed by Maxwell. Maxwell proposed this theory. Electromagnetic nature means it can be produced by the change causes in electric and magnetic fields also. This light will be produced and propagated. Such a theory given by Maxwell. So it is called Maxwell's electromagnetic theory. And quantum theory. In this theory, we can discuss about black bodies radiations also light will be propagated. So how it will be, that thing can be given by this quantum theory. It is proposed by Max Planck. Max Planck proposed this theory. So in chemistry part also it will be there. Planck's quantum theory. So for saying the Bohr's model of atom, it is also take an important role there also. So this Max Planck proposes this quantum theory of light. So in this manner, these four different theories explains about the nature of the light. Then another thing in this will be important property of the light. So before stating this property, according to the nature, light will be propagated and produced. For that, the media in nature will be classified into three types. Three media will be considered for this explaining this nature of light or propagation of the light. That's called as transparent medium. Transparent medium and transparent medium. Transparent medium and opaque medium. Opaque medium. So these three mediums are there according to the light propagation. According to light propagation means light should not propagate in all these. So medium means according to the light which can be produced and propagated is said to be the medium. So air, glass, water, etc. These are all said to be the medium. So that all belongs to this transparent medium. Air, water, glass, etc. belongs to this transparent. In this, light is easily propagated from place to place easily. That's why it is said to be the transparent. So it is a very important medium for the propagation of the light. You can see the light means compulsory one of the medium is there. So due to that we can observe this light. And another one is transparent medium. Light will be propagated in a special way. Such a special way we call as a transparent medium. For example, to observe oiled paper. Oiled paper. So to take one white paper. So a white paper is not actually propagation of the light. To be oiled it, to make it oil for that paper, and you have to see. So other side slightly it will appear, not clearly, slightly it will appear. Such a type of medium we call as a transparent medium. And opaque, it opposes the light propagation. Light do not propagate it through this medium is also very important. If light do not to be propagated, that can also be considered. So one of the important property will be based for these opaque bodies. So opaque means in which medium light do not be propagated. Such a medium we call as this opaque medium. For example, this blackboard, wall, this duster, paper. So all this light do not be propagated. So wall, paper, this blackboard. Understand? So through all this, the light do not be propagated. So when light falls on it, it will come back. It do not be propagated like transparent medium or in special manner of this transparent medium. It's a different from like two medium. Okay. So such a medium we call as a opaque medium. So by basing this opaque medium, we can consider one of the important property of the light. That property mainly it shows two important properties. One is reflection of light. Reflection of light. And another one is said to be the refraction of light. Another one is said to be refraction. Refraction of light. Now our topic will be this refraction of light. So light having these two properties, reflection and refraction. So in lower classes for this CBSE syllabus or now also have this some reflection property also have, but for SSC state board only refraction property onwards it will be given. Okay, so first reflection, then after we discuss about the refraction. Reflection means when opaque body will be placed for the propagation of the light ray, it touches that and it will be comes back. It will be comes back. For example, to be considered is the opaque body. So it is the opaque nature. For example, to consider a mirror, mirror also be taken as opaque nature. That means when light falls on it, it will be come back. Understand this? So you can see the mirrors now. In that our image will appear there. So due to this property, due to this reflection property. So here we can consider this M dash is the reflecting surface. It is called as a reflecting surface. For this reflecting surface, to draw one normal line is said to be the normal line. ON is said to be the normal line. When light produced from the source and propagated, such a light ray is called as incident ray. Is called as incident ray. Incident ray. The ray which is produced from the source is said to be incident. Remember that incident ray. Incident ray means the ray which is produced from the source and it will be propagated in straight line. Actually, this opaque nature is not there. That means this plane surface is not there. What happens? Light will be travel in straight line like this. So light propagates slightly like this. But this opaque surface will be there. Due to that reason, when light touches this opaque surface at the point of incident, is called as incident point. O is said to be the incident point. At the point of incident, it comes back. It comes back. Such a ray we call as a reflected ray. It is said to be the reflected ray. We call reflected ray. Understand? This is a reflected ray. When it will come, when it touches this opaque body, then only if opaque bodies will be there, then only this property we have to observe. Suppose transparent will be there, we can't observe this property because light travels in straight line. It do not come back. That's why we can't explain this property. For explaining this property, compulsory we need opaque body. Opaque will be important. When touches or plane surfaces to be taken. When it touches that, then the ray will be comes back. Such a property, such a ray we call as a reflected ray. It's called as a reflected ray. Here, for this normal, this incident ray makes certain angle. Similarly, this reflected ray also makes certain angle. Such angles we call as, this is called incident angle. This is called as reflected angle or angle of reflection, angle of incident also we call. That means when the light ray touches this plane surfaces, so for this normal it will make certain angle. Understand? Such an angle we call as an angle of reflection. Similarly, when it touches this opaque nature, it will come back. Such a ray makes with an angle of this normal line. Such an angle is called as angle of reflection or reflected angle, whatever you call. So, okay, this is the reflection property. Okay, so another property of light we call as a refraction property. For explaining this property, we need compulsory two media. Two mediums are required to explain this property. Refraction to be explained by considering two mediums are needed. Here only one medium it will be happening. But refraction does not take place in one medium. Compulsory, we need two mediums. Two mediums are needed. Then only we can explain this property. Such mediums we call as rarer medium. Rarer medium, and another medium is said to be denser medium. So compulsory we need these two medium, rarer medium and denser medium. These two mediums will be there, then only we can observe this property. So in this what happens, red ray travels from rarer to denser and also denser to rarer. Whatever, if the ray produced from the source, wherever it in a denser or rarer, it will be refracted in another medium. Such a property we call as refraction of light. So how it will be happening to light observe. So to consider this the medium temperature or otherwise interface. It is also said to the interface of two medium. Here first medium is there. Here second medium is to be considered. First medium, second medium. Okay. And this first medium here first we taken as rarer medium. Rarer, and this one is taken as denser medium. It is denser. And for this also to plot one normal line. Normal line, it considered as O, N and N dash. So in this medium also this line will be prolonged. So it's taken as O, N dash to be considered. Okay. Now the light ray produced from the source is said to be the incident ray. Here also incident ray is important. So this denser medium to be is a denser medium. It's the ray produced from the source is said to be incident ray. The incident ray is an incident ray. Incident ray. This incident ray touches this incident point here. What is this? Interface, or otherwise medium separator. When this medium separator is not there, what happens? This ray will be travels in straight line. This is the property of the light. It travels like this, straight. But here we place one interface between these two media. That's why what happens? When the ray produced from the error medium, that is an incident ray, touches this interface, there it will be bends and travel. Remember that, bends and travel. Such a property is called refraction. That property is said to be the refraction. When it touches, it will be, see, slightly bends and travel. Slightly bends and travel. This ray is refracted ray. It is said to be the refracted ray. So in this condition, what happens? Ray produced in denser, rarer medium and travels in denser medium. So it will be what happens? Slightly bends and travel. Slightly bends and travel. So we have observed that one simple demonstration. To consider one beaker, in that I had to place one coin. So first I had observed, say, in one medium, to place the coin here. So to place the coin in this, it not be appeared at the larger distance. Now it is only one medium will be taken, that is only the glass. Now in this glass I had to pour some water. So water to be placed in it. So to be observed here, it will be rises up, slightly it will be rises up and bulging nature. When light ray travels in two media here, glass and water, to be taken two mediums over here. So that's why it will be appeared. See, before that we can't be observed at larger distance this coin. Then when water is poured in it, we had observed that it will be slightly bulging. So and also it will be rises up. Why it will be happen means due to this refraction property of the light. So due to this refraction property, we have to say it will be slightly rises up when a ray travels from rarer medium to denser medium. Okay. Here some conditions will be there. Here also to observe when this ray strike this interface, it can also make certain angle with the normal. Such an angle is called as angle of incident. And the refracted ray also, after touching this interface, the ray will be traveling denser medium. It can also be make certain angle with this interface. Such an angle we call as refracted angle or angle of refraction, whatever you say. Now here three conditions are there. When the light ray travels from rarer to denser medium, observe that three conditions will be there. So very important condition. One is when light travels from rarer to denser. Rarer to denser. First point will be when the ray travels from rarer to denser. First point will be what happens? The ray travels from rarer to denser medium. It will be slightly bends and travel. So bending nature of the ray, we have to say is refraction. This bending ray to observe, it is slightly nearly equal to this normal line. That means it moves towards the normal. So it moves towards the normal. This is the first condition. Remember that when light ray travels from rarer to denser medium, the refracted ray slightly moves towards the normal. So which ray? Refracted ray moves towards the normal. Towards the normal. So remember this point, first important point one. And another one is said to be here, incident ray makes an angle of incident and refracted ray makes an angle of refraction. This angle of incident is less than that of the angle of, that is angle of incident is greater than that of the angle of refraction. That is angle I is greater than angle I is greater than angular. So anguli greater than angular. Remember this condition. Anguli greater than angular. So incident angle is greater than that of the refracted angle, or refracted angle is less than that of the incident angle. Whatever you say. So another property will be here to consider velocity of light in radar medium taken as v1. If medium changes, velocity of light also changes. So three important properties of waves will be there. So you know that one is velocity of light, another one is said to be wavelength of light, so wavelength property, and frequency. These three are the important properties of the waves. So here also for this light waves also I had to consider that. So here v1 is the velocity of light in rarer medium and v2 is the velocity of light in denser medium. Now velocity of light in rarer medium is greater than that of the denser medium. That is v1 is greater than that of v2. v1 is greater than v2. Why? Because the wavelength property. So do you know the property of wavelength? Wavelength means so these three properties to remember today. In next class I will continue. So what's the properties of wavelength and frequencies and how it will be variated in this slides. Okay. So thank you. We'll continue tomorrow.